Oh, yes, yeah. What?
No, let's not do that. Okay.
1 and 3 tomorrow. Okay, no problem. Yeah, that's fine. So very good.
Okay, so match these up to their graphs.
I'm guessing y equals x squared is p.
Yeah.
X squared plus y squared equals 25 is q. Y squared equals x is r.
Yeah. And so
And then, yeah.
that's it. And so what you'll notice is that the last two, y squared is equal to x, isn't the same as y equals square root of x, because that would be plus or minus. For this one you have plus or minus. That's why you have the positive and the negative. This one you have just the positive. Let's see. For p, no, I'll get there. I'll come back to it. I won't skip ahead. Sorry. When x, what is y when x is 4 for each of these?
Y equals 16. Y equals 2. This one I'm going to have to actually do back out. 4 squared and 25 minus 16 is... what's 25 minus 16? 9, so y is 3.
Okay.
And then y equals 2.
So let's say this second one, y squared equals x, x is 4. Is there any other number when you square it you get 4?
Minus 2.
Correct. So that's plus or minus 2. This one here, you said y squared equals 9.
So plus and minus.
That's right. Okay, got it. So y equals x squared plus 1 is an example of a rule for a function. Each input gives exactly one corresponding output. So when you put in x equals 3, you get y equals 10. Let's see. So these ones, when you put in one value for x, you get one answer for y. Which of these are functions? Which of these are not functions?
If it's what is it called when you have one answer for y?
So if it's a function, that means for every one input for x, you get one output for y.
So...
Or one solution for y.
Yeah, so function is the first one and the last one.
Yes. And then these, why are these two not functions?
Because they have two outputs.
That's right. How about this one? Which of these are functions, which are not functions?
The same, isn't it?
Oh, they're exactly the same. Yes, sorry. They're exactly the same graphs. I forgot. So this one is not a function. Yes, because it's got 4 or minus 4. So which of these are functions, which are not functions?
The first one is a function.
Okay.
Isn't it?
Yeah.
Second one isn't.
Yeah.
That one's a function.
Yeah.
Is that one a function?
Yeah.
And that one isn't.
Yeah, that's right. Because that's an odd number. So let's say the cube root of minus 1 would be just, minus 1. This one, though, the fourth root could be plus or minus, because you could split y into r squared. Okay, what about this one?
Can you put the question like a little bit down? Sorry.
Oh yeah, I keep forgetting your thing. There was a boy who I used to tutor who had something except for the left side of the screen, and then one day he just pressed something and he was able to see it. So there might be something on your screen that you can press or something. I never really see it from your side, so I don't know. But yeah, that's why all my stuff is always in from the left, because he never used to be able to see the left side of the screen. And then one time he pressed something and he could see it, and I was tutoring him for a year. It was only after a year that he found it. But anyway. Okay, what would this one be?
Oh, I've just done something. Wait, hang on. Oh, I just made it worse.
Oh, did he? I think maybe he pressed something like that and it made it big or something.
Oh, no, actually made it worse. For the rule y equals root x, you find the value of y when x equals -5, so root -5. Oh, my calculator's not here. Hang on. I've actually made that worse.
Or maybe he slid it. Is that what he did? I don't know.
Can you slide it?
See, maybe he was on an iPad or something and
he... Yeah. Hang on, I'm just going to calculate that.
Okay.
Root 5. I mean, you can't do root -5.
Correct. So, no.
Oh, brilliant.
So the domain is the possible x inputs. So for y is equal to the square root of x, because you can't square root a negative number, the domain is x is greater than or equal to 0. So the domain is the possible inputs, the possible x values. Okay. So the rule tells you how it's calculated, and then the domain, this tells you a set of values for which the rule is applied. We can use letters to stand for functions. So I'm sure you've seen this before, the f of x. Yeah. Okay.
Yeah.
So sometimes you will get the context of a question. Yeah. Okay, this one. A4, read it, try it.
The radius of circles R, the area of metal remaining is AR, which of the following is a rule for the function of A? A circle is cut out of a square model. Circle is centre of the circle is centre of the square. The radius of the circle is R. Area of metal remaining is AR, which of the following is a rule for the function of A? Okay. So I want to find out the grey part.
Yeah. And if you were going to find out the grey part, so what is the possible values for R? So this time it's called R instead of X.
Is it the second one?
And why the second one?
Because if you find pi squared is the area of the square, the circle, and then 100, the whole area is 100, the whole thing.
Is the rule for the function pi r squared. So to find the grey bit,
Find out the rest of
So what would be the total area of everything?
100
Okay. So if you took away 100,
from the area of a circle, you'd get the rest of.
I think you'd get a negative number.
Okay.
Surely.
So minus pi r squared then.
Yeah, 100 minus pi r squared. That's it.
Okay.
Yes.
Oh yeah.
Okay. 100 minus pi r squared. And okay, what is this one?
Uh, 71.73.
Looks good. What does that represent in the context of this question? The a of 3.
That the radius is 3.
Yeah, when the radius is 3. Go on.
When the radius is 3, the area of the meta remaining is 71.73.
That's it. Which is an appropriate domain. So what we found was the output. What would be an appropriate domain?
You could shut the door though. Oh, okay. It can't be more than 10. I feel like.
Definitely can't be more than 10.
So the third one?
Okay, so what if R was 6?
Or the second one?
If R is less than or equal to 5?
Yeah.
Is minus 1 less than 5?
Oh yeah, true. So it's got to be within 2 like boundaries.
Yeah.
So it can't be 10, it can't be 100. It's gonna have to be that one then. Second last one.
Yeah, between 0 and 5. That's it. Because it's the radius, it's already in the center, so it can't be 10 long. It would have to be 5, and obviously can't be negative. Yeah. There we go. Okay, you have to sketch this graph. Any idea how you do that?
Make a table. Find FX. What does it mean by that? Exclude input values that are not in its domain. What's the domain? Is it just
the domain x is greater than or equal to minus 2. So how would you sketch it if there was no domain thing?
U shape, but up one.
Yeah. So it would look like something like that. And because the domain has to be greater than or equal to minus 2, when x is minus 2, what do you get?
5.
And so, let's say this here is minus 2. Let's say, I don't know, this here is 5. And we just put a circle. And for inequalities, if you remember from GCSE, will the circle be filled or unfilled?
No.
This one is greater than or equal to.
Not filled?
If it was not equal to, it would be unfilled. It is equal to, and so
it's filled.
it's filled. So it means that a possible x value is -2, and a possible output value is 5. Excuse me.
Okay.
And that's what it looks like. The two different ways.
So you just don't draw that part?
Yeah, and it's probably easier to even just draw it and rub it out.
Yeah.
Any questions there?
No.
Okay. This here, x is an element of the real numbers. X belongs to the set of real numbers. It just means x can be any real number. It's because in further maths you have things called imaginary numbers. What you see this one here? What number can t not be?
Two.
Why?
Because you can't do 1 divided by 0.
Correct. And so you just need to do, so t can be any real number, but t can't be 2. Sketch this graph. No, fine. Sketch this. Okay, how would you sketch this graph?
Does it have like an asymptote?
Yeah, what is the asymptote? Or the equation of the asymptote?
Does it cross 2? No. What was the question?
Sketch the graph.
There'll be an asymptote because it's like.
So, what is the equation of the asymptote? Like, where is this asymptote?
I don't know. Can I just put it in the calculator?
Yeah.
Okay. Okay, so basically it looks like. What was it really an asymptote? Wait, hang on. Maybe you can zoom out. It just looks like one of those like exponential graphs.
Yeah, that's because it is an exponential. And so it goes like that. What's the y-intercept?
I believe it is 1.
Yeah. What is the equation of the asymptote?
Y equals 1.
Looks like went under 1.
Under 1.
So in my table,
Wow.
so the more negative it gets, what does it get closer to?
0.
Yes, so it's y equals 0. Yeah, so the equation of the asymptote is y equals 0. Basically the x-axis. Any questions about that?
How would you work like the equation of the asymptote out anyway? If it wasn't y equals 0.
Well, if it's y is equal to a to the x, the asymptote will be y equals 0. Basically, the more negative the power gets, it'd be, if like in this case, if it was 2 to the minus 100, that'd be equal to 1 over 2 to the 100, which is a tiny fraction. So 2 to the power of 100 is a huge number, but 1 over 2 to the 100, like if you had 1 over 99999, that's going to be a tiny fraction. But they're all y is equal to a to the x have an asymptote of y equals 0. It's only if they transform it. So if they said y is equal to a to the x plus 3, then it would shift 3 up. That type of thing. Okay. So they didn't need to say 4. Oh, was there a domain? Oh, I must have cut it out of the question. Yes, that's what they always look like. No, fine. So here you can see this equation of this function, and they just cut it off for the appropriate part.
Oh.
Okay. This is another way of writing the equation of a function f such that x maps onto x squared. It's like the f of 3 is equal to 9. The f such that 3 maps onto 9. Sketch this graph now. Let's see. Okay. This one, the range, too tricky. I need to do those later. Okay, I'll do B. I just don't want to spend a lot of time doing sketching graphs of functions, because it's a different topic. It's kind of just revision. Where's my thing gone? Yes. A, B. Okay, B. There we go. Fine. Okay, a many-to-one function means many inputs give you the same output. So for this one, the f of x is equal to x squared. Put in 2, you get 4. Put in minus 2, you get 4. Any function which is not many-to-one is one-to-one. This one, why is this a many-to-one function?
Because you can get there's different inputs to get the same output.
Yes. So let's say this here. This. Now different inputs give the same output. So give me an example.
Um.
Oh, I think that's a fine one actually. So if I just draw that line across, yeah. So all those inputs, that x value. When x is 0, you get 1. When x is 1 point something, you get 1. And when x is minus 1 point something, you get 1 as well.
Mm-hmm.
Okay, many-to-one function. Okay, let's try this one.
So just find out what it looks like, which okay, so it looks like okay, so the graph looks like
You might not need the graph.
but why not? Okay, so 1 cubed is 1, 1 minus 1 is 0. If 0 cubed, that's 0. And then minus 1 cubed is minus 1?
Yeah.
Minus 1 is minus 2.
Minus 1 minus
Minus 1 is plus, so 0.
Yes. Part B?
Is f a one-to-one function? No.
No. Many inputs, same output.
Yeah.
Okay, each of these is one-to-one or many-to-one. That'll just be a sexer.
1 plus 1 squared minus 2. Is a one-to-one?
Sorry, this madhouse.
Is A 1 to 1?
A.
Unless you count -1 and 1 being two different.
If you put in 1, what would your answer be?
-1.
If you put in -1, what would your answer be?
1.
What
1
is it?
minus 2 is -1.
And so?
Yeah, so do you count 1 and -1 as different? So would it be like many to 1?
Yeah.
Okay. Well, can't you set with all of them then? Oh wait, apart from n cube, I guess.
Why is that?
Because it would like -1 cubed would give you -1, whereas 1 cubed would give you 1.
And I think as well, it doesn't have any repeating y. So it kind of goes like that. C. What about C?
Does that arrow mean anything, or is it just there?
Sorry?
Does that like arrow mean anything, or is it just there? After T.
It's just a different way of writing the f of x equals f such that t maps onto.
Okay. So if x equals 4, that would be 12 plus 5, which is 17. If t equals -4, that would be -12 plus. So it's 1.
Yeah.
1.
And that would look something roughly like that. And so there's no repeating y values.
Then x of 4 is like many to 1.
Yeah. That's it. And same thing. Even number x to the 2, x to the 4, and then odd number n to the 3, t to the 1. Yeah. Okay, many, want many. Grand. C. This was the one. So when we finish this one, then I can go back. If it downloads. I don't know what you want from me here, Zools. I got this because it was supposed to be faster than Google Drive. Download blocked.
Oh, speed.
Here we go.
Oh.
Range of a function. Basically, range is the possible outputs. So the domain is the possible inputs. Range is possible outputs. Yep. So this graph here, the minimum is 2, 1. And so the range is the f of x is greater than or equal to 1. And because it's a function, we don't say y, we say f of x. Let's see. So how would we do this?
Draw 2x plus 1, where draw a sketch graph of the function of 5 and 5. Would you just make a table and do to substitute the x for -3 to, well no, it would be -2, -1.
And so
So its range. It's already given the range, hasn't it?
that's the domain.
Oh.
So when x is -3, what do you get?
2 times minus 6 minus 5. And then 8x plus 1 is 9.
And so what is the range?
Minus 5 to 9.
Yeah. And so y in the middle,
Yeah.
minus 5 to 9. Fine. And they wrote it with the empty circles because it's not or equal to. Okay, range of this.
Okay, draw the graph, which is just like that. State its range. Any real number. Real is just if negative is a real number, isn't it?
Yep.
How do you do a range if it could be literally any number?
So this is the domain.
Yeah. So the output would be whatever. Substitute the t, but
Could the g of t be minus 1?
yeah.
So if I extend this graph, is it eventually going to go down to minus 1?
Oh, like go down there.
So what is the range of this graph?
Can it be 0?
How would I think it will get close to 0 but never touch it.
There's a 1.
It could be a half.
Okay.
So the way you'd say it, is it's greater than 0. But because it doesn't touch the line, it's not or equal to. It's just greater than. So yeah. G of t is greater than 0. So that's, exponential graphs in general. Okay, range for this one.
Okay, so draw the graph, and then x is greater than 1. So if it's 6 over 3 is 2, so it'll go greater than 2.
Why is it 6 over 3? So I would
If you substitute the x for 2, because x is greater than 1.
Could x be 1.5?
Oh, that's so stupid. Yeah, so x is greater than. Is it just the same?
Well, I would sub in 1 for x and see what you get.
But you can't do that, can you?
So if you could, what would you get?
6 divided by 6 over 2.
Which is?
3.
And so the f of x can't be equal to 3. What would you say about the f of x?
Was it a...
What about when x... okay, so, well, what I'd say is it's less than 3.
Why?
So I think you need to sketch the graph. So if this was an exponent, if this was, what type of graph would this be?
Bella.
Do you know roughly what the graph would look like? Or what type?
Like a... that one, those
Reciprocal, yeah. It's been transformed slightly. The 6 on top won't change much. What will the plus 1 do?
Move it to the right.
Transformations always have the opposite signs.
Move to the left.
Yeah, it'd be translated by the vector minus 1, 0. So that's going to be moved 1 to the left. So this is when x is greater than 1. So that's like just this part here. So when x is 1, y is 3.
Yeah.
And so it is, the graph is going to be, oh, hang on. Will the graph eventually become -1?
No.
And so how would we fix this? Because -1 is less than 3.
But it won't become -1, will it?
No. And so how do we fix our range?
Just greater than 3.
Well, it starts at 3 and goes down, but it gets close to 0 but doesn't touch it.
So f of x has to be either, it goes from 3 to like greater than 0.
Yes, and so it's basically f of x is between 0 and 3.
Yeah.
That's it. Tricky one, reciprocal graph. That's it. Any questions about that? And so you don't put in the first integer value for x, like x is 2. That would be the first integer value. But x is any real number, and so it's it could be 1.5, 1 1/4, 1 1/100th, and so you just put in 1 and you use that as your boundary. This 0 is the lower bound and 3 is the upper bound. Okay. And now I go back, sorry, to the very first one. This one. Yes. Okay, this one. State the range of f. Exam question.
Yeah, so if we draw the graph, it would be 10. Okay, so the graph is like a UE, an upside down one.
Yeah.
And is it not given a domain? What do you do if it hasn't given a domain? Do you just use the...
You'll know the domain. The domain is domain is any number, any real number.
Okay, so do you go from like the maximum point and then... Do you know what I mean?
Right, and so what is the maximum point?
-310.
Yep. Okay. And so range?
Is that our range?
Well, that's the maximum. What is the range?
Has to be... It can't be greater than 10.
Right.
So for like f of x in the middle, and then like less than 10, less than or equal to 10, isn't it?
Yeah.
And then greater than or equal to -3.
It can be -3, can't it? You can get -3 as a y coordinate.
Yeah.
Fx is like y. That's it. This one can be negative. Basically, the y coordinate.
Just leave it like that.
Sorry?
No. Do you just leave it as less than or equal to 10?
Yep, because so the f of x is like y. F of x equals y equals, yeah?
Okay, yeah.
This is a graph of y equals the f of x. So they're asking you for the possible y coordinates. So the y coordinate, the maximum y coordinate is 10, but then it can be any number. It'll keep going down. Yeah. Okay, this one. State the range for this.
So the y-intercept is 0, 2. So is it just less than 0, 2? Less than or equal to 0, 2? I mean, less than or equal to 2.
Or equal to 2. Yep, that's it. And then this tricky one.
Define over and gx, find the range for f. Function, I need to find both real values. So just get the graph up, which is so the graph is just a u.
Okay.
And the minimum point is 1.5 minus 9. So f of x is greater than or equal to minus 9.
Minus 9. That's it. Any questions there? Oops. Okay. Let's try this.
Okay. Oh, that's well hard. For half pi has to be greater than or equal to half pi.
That should be minus, I think. This website took these exam questions and just put them in. And that should be a real number.
Right. Right. Okay. That is minus half. Half. No, I'll do that. No. Because it's just that there's so many like.
Think of the sine graph.
Yeah.
Okay, what's the range?
What is the range?
Of y equals sine x.
I don't know.
What are the possible y values? What's the maximum?
1
Minimum?
minus 1.
Range?
Minus 1.
Okay. So this one is 2 sine x.
Yeah. So just times it by 2.
I believe so.
So minus 2 and 2.
So there's other stuff we didn't take into account, which is it's between this and this. When x is a half pi, what do you get? For 2 sine x.
2 sine half pi. Oh, cool. 2 sine.
I'll have to switch into radians.
Oh, we're learning that now.
Shift mode radian.
What'd you get? Oh no, yeah, I've changed ranges. Two.
And when we put in minus a half pi,
Minus 2.
yeah, and that works for all of these, that they're all transformations. And this is like a transformation, stretch, y direction, scale factor 2. And so, what's my final answer? Oh, hang on. We didn't read the question.
Yeah.
State the range of G. We've found the range of F.
No, go back. State the range of f and the range of g.
Oh, okay, good. Phew.
2 x squared. Okay, 4 minus 2 x squared is like a massive UE.
Yeah.
The maximum is 0.4, so gx is less than or equal to 4.
That's it. Any questions about that?
Nope.
You're happy with yourself. So let's see. So that's.
It's not going to be this easy in real life, is it?
Sorry?
It's not going to be this easy in the exam, is it?
These are past exam questions, but.
Yeah, but it's like 2007. I feel like they changed it now.
Okay, so, well. Let's see. So. Y-E-A-R. Pearson. That's the thing. Year 2.
Because I feel like I always do these, and then it comes to the exam, it's like 10 times.
Like, these were just part A, because we're only part of the way into functions.
Oh yeah, true.
Functions and graph, so modulus, composite, inverse. So I, excuse me, I did further in functions. Okay. Let's see. So I just wanted to check with you. Where is it? Here's my thing. So have you previously done the composite or inverse functions? No? Okay, great. So that's the reason why I skipped ahead to this, was because I thought there's a chance you did composite and inverse functions. But I think actually you were the last year that didn't do those at GCSE. And so, okay. So, right, I'm going to put it here. So if you like, we can do those next.
Yeah, what are they?
Composite functions is you put something into a function, like the f of 3, and then you put your answer into another function. And it gets tricky when you have to put in like x plus 3, so algebra.
Yeah.
Inverse function is the reverse. Okay, so what is a function?
When you haven't. Are you asking me or are you just saying?
Yeah, asking it.
When you put in one input and get one output.
And there's another type of function.
What's the type of function?
Many to one.
Many to one and one to one. One and one.
Yeah. So a function, there's one unique output. And we saw somewhere the output. Yes. So a circle, for example, when you put in x equals 3, you'll get these two different y values, and so it's not a function. Okay. And let's think of our sine graph for a moment. Is the sine graph a function?
Yeah.
Is there some value for x where if you put it in, you would get two outputs for y? So if I put in x here.
That's putting it there, yeah, true.
And so the way you turn sine x into a function is you limit its domain. And that's why they said this function sine x is between minus pi and plus pi. It's to create a function. So if you have this and it's not a function, you can cut it so that it starts from here and stops there.
Yeah.
Okay. What is a domain?
A set of like values you input.
Yes. What is range?
set values without.
Yeah. And so we did that for real world examples, which is modeling, graph sketching. Yes. Why was the domain for this one the range t is not equal to 2?
Because you can't divide by 0.
Yeah, and that's always true for any fraction. You'll see these in exam questions, but t is not equal to 2, and you'll think, like this bit here, and you'll think, I don't understand this bit here. If you ignore that, you'll be fine. But that they're just saying where it comes from. So t is not equal to 2. You see this all the time in exam questions, and you've no idea what they mean. If you ignore them, you'll be fine. T can be any real number except 2. Obviously. So I don't know why they even say it, but who knows. Yeah, they always put it in. This one, asymptote. Yep. If you're sketching a graph and it has an asymptote, it's always good to put in the equation of the asymptote. This is just a different way of writing the f of x equals, still for functions. And these exam questions we did, many to one, we looked at. Yep, many to one functions. And then range is possible outputs. Yes. How'd you find that, Saba?
Alright, pretty easy.
I'm glad you found it easy. Okay, any questions for me in general? Well done. You're doing great. I look forward to talking again next week.
Okay.